Welcome to Web Handling. My name is Dave Roysum. I'm super excited to continue our new series on zero, which is not nothing. It is something entirely different, as we will see. In this final episode on zero, we define zero in web handling for motor torque, how to find it, and what web units are appropriate. As we saw in last week's show on NIPS, friction must be measured first. Let us begin with the DC motor ammeter that effectively mirrors motor torque. Below on the right is an example ammeter that can read from minus 20 to plus 20 amps as shown on the inner scale. Note that AC vector drives and servo drives may display torque directly as a computational model, but the principle we describe here is exactly the same. To understand the ammeter, we must first define zero in web handling and then friction before any calibration can continue. Let us define zero in web handling in the most natural way. That is, there's no tension change going across the roller. In other words, the outgoing tension T2 equals the ingoing tension T1. If we put in no motor amps or no motor torque, T2 would actually increase due to the drag of the motor, gearbox, and roller bearings. Note that during a speed change, we would need to add an inertial component. The motor must output a value that we call no load motor amps in order to have the motor-driven roller do nothing to the web. No load means no external load, such as from a tension change. On this example, we see that it takes 7 amps of current to just overcome the drag and do no work on the web. Thus, T2 equals T1. If we put in 8 amps, the tension will actually decrease, as shown in the outer scale. Even if we put in 6 amps of motor torque, the tension would still increase because it's not quite enough to overcome drag. In conclusion, there's a one-for-one correspondence between motor amps or torque and on the inner scale and the tension change going over roller, the outer scale. However, this is a bit confusing to the layman because 0 amps is not zero effect on the web, meaning also that turning off the motor still leaves an effect. Also confusing to the layman is that more motor torque means less web tension after the motor. However, as everyone should know, friction is complicated. Thus, for example, it will vary from night to day if the plant is not well temperature controlled. Worse yet, it will vary enormously in the first hour after a cold start. The elements most responsible for this temperature effect on drives, and thus tension, are rubber covers, gearboxes, and liquid coatings. Probably the best element to explain these complications is the common boat roller spreader. Without going into drive control details, suffice it to say that this must be a torque assist drive rather than speed control. The motor must put out just enough torque to overcome cover flexing hysteresis as well as bearing drag because there are many bearings. Thus, best practices are to first run the boat roller for 24 hours, then do a first measure of no-load motor amps as a function of speed. That curve is then input into the torque command to the motor. Then, after a month or so, we need to retune again. As a final note, motor units are the same as tension and nip. PLI in the English system, kilonewtons per meter in the metric system. I hope you've enjoyed this overview of zero, friction, and calibration on everyday web machine components. This is the last episode of this series and for 2024. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next year.